Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, and welcome back to the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show, now over 2 years going, that we designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every single week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, here we are again.
Yep, here we are. And, I just took a week off and saw flowers in Holland, Michigan, which is a cool thing we do up here. And it was good to get away and actually go out in a crowd. It wasn't, a lot of people, but things are looking better. Thank goodness. It's been a long journey. I've been vaccinated. I think you have too. Yep. So it's really good to be on this side of the curve of this problem.
Yep. Well, I've been vaccinated too, and I was on the other side of Lake Michigan this weekend. I was in Chicago visiting my...
Didn't you hate the cold weather?
It was like 48 degrees the whole time. And being a Texan, I was like, wow, I need a sweater. But my wife and I actually went to the Chicago Botanic Gardens and looked at flowers. So that's exactly what I did last weekend.
Yeah, that's what we do. We keep wanting real spring to arrive, which means it never goes below 40 again. But in any case, it'll be here shortly.
It was all good. We had a good time. My daughter and son-in-law bought a house, so we got to stay with them and see their house. And when I say my son-in-law, that would imply they actually got married. COVID actually canceled their wedding. So it's really my daughter and her fiance. But I told him, I'm just calling you my son-in-law from now on.
Yeah. Well, you're going to do the wedding, right? I mean, you're planning it now?
The assumption is they're going to do the wedding, but they might wait till 2022 just to be sure.
Oh, yeah. Depends on how many guests you want to have and where.
That's exactly right. So every single week, Craig and I try to bring to this podcast really interesting people and interviews where we're going to get some ideas that are going to help all of our listeners enhance and grow their careers. And today we have Phil Zimmerman. Now, she is the Director of Engineering for Tools and Environments in the Office of the Undersecretary of Defense for Research and Engineering. And Phil, that might be the longest title I've ever read of any guest on the Digital Enterprise Society. And what she does is she finds methods and processes and tools to improve engineering practices, and then she introduces them and makes them real for the Department of Defense. So Phil Zimmerman, welcome to our little podcast.
Hey, thanks so much. I'm really excited to be here. This is, I actually wish people could see you because you're very interactive, even with, with your hands and stuff like this, but I'm really excited to be here. I'm not a PLM practitioner, so let me apologize. I guess maybe the best way to do is apologize for that up front. But I am a strong believer in the rigor that we can get by doing our engineering jobs, whatever they are, in a computational space, which is what my job is all about.
Well, you don't have to be a PLM practitioner to be on this show. I'm not a PLM practitioner, but that's why we have Craig. So Phil, tell us a little bit about your background. How long have you been working for the government, and what led you to where you are today?
Yeah, so I've been with the government 25 years almost. 25 years July, around that time frame. I actually was a contractor beforehand. I've always been involved in the defense sector. First as a contractor, I worked for some contracting firms on the East Coast, and then my husband and I decided to join the federal service in 1996. So we've been doing defense work around acquisition, where PLM plays a very important role, but in the acquisition world. So I'm not a trainer. I'm not an analyst. I actually am an engineer. I'm an engineer by, I guess maybe I'm an engineer by declaration. My degree's in mathematics. But my function has always been around how to apply rigor in concepts, either to processing signals, or in the case that I have now, in bringing capabilities to our engineering staff. Bringing capabilities to the engineering staff is probably the best way I think we can right now reform the business practices within the Department of Defense, which is one of the goals of the National Defense Strategy. In between being a contractor and my current job, I had some pretty gnarly things to do with Army's Future Combat Systems, with some modeling and simulation interoperability, and a variety of other smaller efforts, all leading to what I'm trying to do today, which is to improve the engineering practice.
So, Phil, it's great to hear you again. As we were talking before the show, we actually met, or we were in the same room, might be the better way to say it, in Tyson's Corner, which is outside of Washington, D.C., at a conference that SimData hosted, their annual thing they call the PLM Roadmap Conference. And I learned for the first time what you've been championing, which is this Department of Defense Digital Engineering Strategy. And the reason it piqued my interest is because I had other friends who both automotive and aerospace and defense who had met over the years at PLM World, and maybe some of them are listening in, and they're like, wow, this new strategy's been written. We think it's great, but what would you do with it? And of course, at that time, I was just retired from GM. And so, thinking about new strategy and implementation was about the last thing on my mind. but I got intrigued. I was surprised. And so when we somebody in the group recommended you in the Digital Enterprise Society, and I said, well, this would be great because I kind of like to explore how it is you come up with a strategy and why now, So first, let's start with, can you give our audience what is it? What is the Department of Defense Digital Engineering Strategy?
Yeah, absolutely. So it's an effort that it's the result of an effort that we've been doing for years in trying to find a way, as I opened up with, to improve engineering practice by taking advantage of the great computational power we have today. I mean, I even marvel sitting around in my little home office. I've got 2 phones and 3 tablets, and just the amount of computational power I have today is enormous. But it's, how do I take advantage of that and apply it not to the exact problem space, but to make my engineering practices more rigorous? Mm-hmm. How do I take advantage of the computational power that's available to me in things that I maybe should be worrying about, but don't, like history, right? Mm-hmm. The nice thing about the Microsoft suite of products is that they track revisions for you, right? How important is that when I have to do analysis, maybe in the reverse order to figure out how I got here? So there's all of this capability that I thought, wow, maybe it's time that we get it into practice in the Department of Defense. And what would that do to the products that we provide to the customers, which for us is the warfighter? Craig, you mentioned that, that you have a son that's serving. I have a son that just returned. So this is a very real problem for most of America. Mm-hmm. And the nice thing about it, and here's what I really liked about SimData when you and I were in the room for the first time, and I just did some SimData speaking a little while ago. Mm-hmm. The nice thing about it is that these digital practices, and you touched on it with your comments on just having retired from GM, these are practices that don't care what they're applied to, right? I often tell people, digital engineering doesn't have feelings, right? It doesn't care how it's going to be used. And so there's a couple tricks that we've come up with along the way. But anyway, so back to the digital engineering strategy. The digital engineering strategy is the what needs to be done to work in this digital space, to have all of these capabilities. It doesn't say how, and there's a reason for that. In the Department of Defense, contrary to popular belief, OSD, Office of Secretary of Defense, where I work, doesn't have all the money, right? We don't own the schedules. We don't own the programs. Right. So but yet we have this umbrella function. Some would call it oversight. Some would call it grade the homework. I would call it assist, right? How can I assist all of my engineering constituents in the services and agencies to do their job better. And that's how we wrote the digital engineering strategy. And so the services and agencies are responsible for the how it gets done. We get credit for writing down what some people call the obvious, right? Oh my gosh, this is so simple. And that's actually what I would like people to walk away with, is that this was really simple. We wrote it down and provide that umbrella piece that the services and agencies can plug into in order to change their practices.
Yeah, the thing that drove the car companies in this same direction. So how do we take advantage of simulation and all the computers that are now really cheap? And what drove them was just shareholder value, right? Time to market and shareholder value. Finally, we got to the place where we were good enough at repeating manufacturing that what we really needed to do was stop building prototypes and learning from each cycle and then putting it into a product, and it takes 5 years or whatever. And so, at GM, when I had a role very similar to your job before you wrote the strategy, it was all about, well, how do we replace physical testing, road testing in a laboratory? And then better yet, replace the laboratory work with simulation, right? And how do we gain confidence in simulation so we can replace physical tests? So when I wanted to get people interested, we had leadership, gosh darn, it was really good, who just said, if you can save me a $500,000 prototype is what ours cost, right? If you can save me $500,000, I'll reinvest a percentage of it in your simulation backbone, right? And so we had, part of the strategy was, how do we fund this stuff? Yeah. It just came off the top because the vice president said so, right? So we didn't have to fight internally. That really helped us implement the strategy, right? I think people listening to this, especially if they're in a commercial and you said like, oh, well, maybe there's something here I should read. How do they go get more insight or education? Are you guys teaching courses, or are people writing papers about, well, here's what we mean by strategy, or is it just that obvious and people just need to get on with it?
So if you're interested in reading the actual strategy, it's less than 30 pages. It's actually very pretty for a government document. It's actually very pretty. It's got a nice cover and pictures, and you can get it on CTO, Chief Technology Officer.mil. Right, go to the engineering resources, and you can print your own copy of the digital engineering strategy.
We'll make sure we put the link in the notes we put out with the podcast.
Awesome. Yeah. So, but hang on. Well, I'm not done actually, though, because it really has caught on, right?
Okay. Good.
Much wider acceptance than we had ever seen before, including in industry. And so, if you can look, there's tons of papers being written about different facets of implementation of the digital engineering strategy. Right? It has five. Good. It has 5 goals. Digital engineering, DE, although that can also mean directed energy in my world. And anything.
You don't want to stay out of the way of. Okay.
Exactly. Yeah, you wouldn't believe the number of DE questions I used to get in the beginning, and they had nothing to do with what I was doing for a living. And so papers are being written, courses are being taught at most of the universities that have systems engineering curricula, right? This is all about engineering processes, so engineering better. Research is being done. There's a group called the System Engineering Research Center that has 22 affiliated universities that is doing research in it. Sim Data is one that you talked about before. They do regular talks on this. We do a little bit of education for the engineering acquisition workforce, but the best work is actually not being done by the Department of Defense. I think the Department of Defense, the digital engineering strategy, is hurting all of those elements that frankly have been in the workforce long before the digital engineering strategy existed. And I think that's important to note. This isn't something new. Right. This is just herding of cats coalescing, bringing together some pretty critical pieces for the Department of Defense to pay attention to.
Well, and I think you're hitting on something really important. Sometimes it's the senior leadership that frankly needs a kick in the pants to get herded, as you said. We'll call them the cats for the moment. And I think somebody of authority, right? At least, you guys are setting direction for how the Department of Defense wants to work, right? And so it's interesting to me that just having a document you can refer to, then executives at a big aerospace company can say, oh yeah, well, we're going to do this because, right? Yeah. So they can point at something. So that's good. Now you mentioned there's 5 key things, and we don't have time to go through all of them, but I wanted to pick on one because I like the words, but I also, at times I'm a lawyer. Okay. So caution. So the strategy defines authoritative source of the truth. And the words are really important because I think, the old school folks, at least at the car companies, they would say, well, the only thing we trust is build a prototype and take it for a drive and we figure it out. And the really good quality people would sit down and say, what's the variation of the prototype compared to what you mass produce? And, the unseasoned executive would say something like, well, what do you mean? And like, you hand built the prototype, right? You didn't build it with the machines that are on the assembly floor. And so the chances of the variation, just part to part variation and assembly variation, are enormous. So if you don't build your prototype on the manufacturing line that you're going to mass produce on, then how do you have confidence that you're actually seeing the same variation? Simulation could not only match the prototype, but it could show you the variation you're having in the plant, and you could take an advantage of that. So what does the authoritative source of truth mean? It sounds like something that probably is time dependent, but it's important that you have confidence in it, right? That you trust it.
Yeah. Not only is it, so I would say it has 2 features. It's definitely time dependent, but it's also question dependent, or maybe better stated, use dependent. So my authoritative source of truth for a tank is probably going to be different. It's going to have different contents than my authoritative source of truth for a Jeep. Okay, but it's going to have some elements that are the same. If I took that analogy and stretched it even further and now looked at my authoritative source of truth for an airplane, it's going to look much different, but it's still going to have some relationship to the elements of what's in a Jeep, right? They both have tires at some point. They both have transmissions or something similar. And so the authoritative source of truth is there to say that, look, if you're going to do work in a computational environment, in a computer, in a computational space where 1 + 1 always equals 2, it doesn't equal 2.1, it doesn't equal 1.9, and that rigor is really important to us, then when we do our work, we have to have a consistent place to start from. And that's really what the authoritative source of truth is. And I guess maybe the other feature that's maybe now secondary, to the time and to the use is that it isn't static. It will evolve, in our case, as your design evolves, right? So I don't know the exact weight of my tank when I'm first conceiving it. I know approximately how much it is. So my authoritative source of truth might have an entry like estimated weight. As my design matures and as I understand what materials I'm going to use, that estimated weight gets revised. And then when the first one rolls off the assembly line with bumper number 1, it has an actual weight. I know how much it weighs. Right? I know exactly how much it weighs. Well, the different let's say trustworthiness in the authoritative source of truth. I know that almost sounds like an oxymoron, but the trustworthiness of the authoritative source of truth means that you know that you're characterizing exactly what you have in it, and that for all of the activities at that point in time that information piece, that data piece is used for, it's accurate, right? You can't have a discussion about whose analysis is right or wrong if you're starting from different points, if you're starting with different data pieces.
Well, this is a really good point. We've talked with other guests about the order of decisions, right? Whatever your engineering enterprise is, somehow to stay competitive, you make decisions in a certain order, right? In your tank analogy, you're probably worried as much about armor as you are about total weight, and then you worry about range after that, right? Other businesses will put them in a different order. Maybe range is first if you're in a long hauling business, right? So, okay, so we get it. So why? What was the catalyst? I mean, you mentioned you had a couple of experiences, but were there Was there a group of you that said, we really need to write this down, this digital engineering strategy? What was the catalyst?
Yeah, interestingly enough, so the catalyst comes in a couple different forms for me and for my team. But I'm going to tell you that the biggest catalyst came from industry. Industry said, you know what, the Department of Defense really needs to put out what it would expect from these, and at the time it was model-based techniques, right? Model-based systems engineering, model-based engineering. And industry was saying, if we could introduce these into the Department of Defense, we could use that rigor and improve our communications industry to government, right? We have to figure out the intellectual property and all those lawyerly things that engineers don't really want to deal with anyway. But we need to figure out, we can start to use this now as the technical framework for communication. So that was one. The industry was saying, go ahead and do it. The services at the same time were getting maybe even poked by the same industry guys. And the services were coming to us to saying, geez, it would be really nice if OSD could help us improve here. And then personally, having come off of future combat systems where we had 18 different developments going on at the same time, not being able to lay my hands on what's the estimated weight for this man ground vehicle today when I needed it to go in to do analysis was really frustrating, right? Who do you call? Well, you call the PM. Well, he's busy. So let me go to the chief engineer. Well, he's not picking up his phone. And eventually you get down to some, Joe or Josephine bag of donuts way down in the engineering stack who says, well, today my estimate for it is, 42 tons, whatever. And that's only between you and the bag of donuts person at the bottom of the engineering stack. And nobody else above them has it. So when somebody else comes in and says, I need to estimate what this weight is, how do they know how to get to that person? So
now I understand authoritative better.
Yeah.
So, and what's really sad is what you're describing is the car guys went through similar growing pains, right? With corporate average fuel economy targets, you had to know the weight classes because it determined whether you were considered part of trucks or considered part of car. The whole sport utility thing is about categorizing whether you're in the vehicle passenger. Of course, all vehicles have passengers, but the point is we were doing weight estimates based on regression models of, well, last year it weighed this much and we're going to improve this percentage. And so next year it'll be this much. We don't actually know how we're going to get there, but we'll figure that out along the way. Right. And so nothing was authoritative. And it was really frustrating until you built the first one, even if you didn't build it off your manufacturing line. So that's interesting.
Yeah. Craig, one more. Let me just jump in here. You're going to find that a lot about me. One way to think about authoritative source of truth is to use the phrase for the sake of discussion. For the sake of this discussion, we're going to have. This is what I mean. This is what the authoritative data for this aircraft is.
Yeah.
No.
But knowing the progression of decisions you're going to make kind of determines the context of the authoritative. And I think people get lost in thinking, oh, that's the identical thing to what we'll mass produce. The truth is, you know that as you start mass production, as you pointed out. So, all right. So we've talked a little bit about the industry's aware. They were helping push it. I want to draw a comparison, and maybe this is already part of what you answered, but my counterparts in the commercial aircraft companies, they really wanted model interoperability, and by that they really mean not just a 3D model of a fuselage or whatever, but they also meant performance models and things like that they could share. And they've been pushing a lot of the MBSE initiatives. And they kind of were disappointed that we car guys didn't get in there and push even harder because we have more money at stake. And the truth is, we big car guys, we would just tell our supply chains, well, we use this tool and you will provide files in this format. And it's really not negotiable, right? You want our volume. And so the dynamics are really different. And so I think your strategy, what you guys have written, will help this debate a lot. And I think the the supply chains of aircraft, at least for sure commercial aircraft, and especially given what's happened this past year and a half, they'll get streamlined a bit if we can get to some kind of model interoperability. So both a CAD model, a performance model, a thermodynamics model can be shared with your tier ones, tier twos, and all the way down. And then people talk and make decisions like we've been talking about based on those models. So I guess I'm answering the question I was going to ask you, which is, so does the strategy help people streamline, the supply chain? It should help clear up the discussion, I would think.
Yeah, it does, but I have to tell you that think about it. I think about it this way, right? So I've been at digital engineering as a title of digital engineering since 2014. I've been in my current job trying to figure out what it should be since 2010. But digital engineering is in its infancy in the Department of Defense, right? So we have pockets of adoption, and in some cases, really big, important pockets of adoption, right? Good. Places where you want rigor to be, they are rigorous, right? So I'm thrilled with all that. But they aren't quite comfortable enough in this new skin of digital engineering to understand that all of the helicopters, right? One of my favorite examples, because every service in the Coast Guard has them. They aren't at the point yet where they can say, for helicopter development, this is the way we want to exchange information. Yeah. This is what the authoritative source of truth should look like. We can do it across programs. In some cases, we're doing it across program elements, such as heavy ground vehicles, light ground vehicles, fast-moving aircraft, et cetera. But in most cases, the level of maturity that would come from a comfort level has not gotten us to the point where we can say, for this, it looks like this. But there's one really important part that people tend to forget. It's okay if you spend an extra millisecond or two converting from one format to another, as long as you understand what the loss is. Right,
exactly.
Right. Spending a millisecond or two is not something you're going to notice. And it's okay to do that translation up front. So by all means, you shouldn't let the fact that we don't have that commonality or those interoperability standards stop you from embarking on this.
Right. Interesting. Okay. All right. So look in your crystal ball 5 years from now. What has the strategy accomplished?
I think I'm going to cheat at this answer, Craig. A number of years ago, we co-authored a paper with a number of federal agencies in an ad hoc engineering group called. It has this really wonderful title for Interagency Working Group for Complex Systems. And it has the chief engineers from
how do complex organizations build complex systems or something like that.
Well, there is that theory that your product looks like your organization, right?
Well, yeah, so maybe there is something to that, right? We've talked a lot about that.
Yeah,
I interrupted.
That's okay. That's okay. But what we did was we asked the chief engineers across these federal agencies, what would you expect from model-based systems engineering? And I think the most important thing that becomes to me when you figure out the fact that my customer is a warfighter who might be getting shot at pretty regularly, right? Or being in battles pretty regularly. The most important thing is that the system is going to operate as they expect when they get it.
Okay.
Right? That is the most important thing that I think we can bring by using these model-based techniques, this digital engineering, these computational spaces, that we know what's going to happen, right? As we get better at modeling phenomenology, we will get better at being able to tell the pilot in the aircraft, your aircraft is only going to go 495 nautical miles, not 500.
Yeah.
Those types of that type of assurance that we can give them, to me, allows them to concentrate on what is at hand and not on, is my gun really going to fire today?
Well, and this is an interesting, we could do another interview about this, but this discussion about learning from the field and providing quick feedback on the confidence you should have, whether it be range or even well, this old aircraft I've been in way too many hours is going to make one more flight, right?
Yes.
The machine learning stuff that's coming, and the fact that we got sensors everywhere now, and we can collect all this data because we got huge bandwidth that we didn't used to have. It's really interesting to watch this. So this will be the authoritative source of truth in operations. And in fact, you'll get feedback in operations, right? And it'll be cool. So
yeah. But you know what? It's not going to be direct, because I think about that. That poor, sergeant that's standing at a screen, and all he really wants to do is make the screen go away. Right. And what he's got to do is now he's got to he or she has to fat finger all these numbers in to get the report from the field into a format that I can use. Right. Well, that extra step has to be removed. And we now have to be able to communicate directly with the machine, because let's face it, he's thinking on make the screen go away, right? He's not thinking about this data is really important because some poor engineer in the basement of the Pentagon needs to know that it's 1.7 and not 1.6.
Yeah. So this will be interesting. So a measure 5 years from now of success of a digital engineering strategy would be, in fact, that the operator, the sergeant, is able to just interact and make better decisions quickly.
Yes.
Right.
Yeah.
So,
wouldn't it have been great for the guys if we could have known that once you bolt all that extra armor on, your axles are going to break, right? Intuitively, we all know this. And in hindsight, you can say yes, but what's that actual break point? Right. Those types of things are when we can get to a digital operational environment, that's huge. Yeah. We'll never buy it unless we fly it. I'm not saying take the human out of the loop at all.
Everybody listening, that's a real story, because at least my soldier had this story about, he works on ground vehicles, right? And he had stories where they put on he was in Afghanistan, they put in more armor and then stuff broke. And then, they're like, how come you, and he gives his dad trouble all the time. He says, how come you engineers don't do that? And I said, well, we don't engineer military vehicles. If we did, we wouldn't have that problem. But anyways.
Oh, you probably still would. And let me say one more thing, right?
We also add armor to Cadillacs for presidents, but never mind.
I also think that a success of digital engineering is to not think about it as something special. It's just part of the way the engineer works. If my son ever comes back to me and goes, Mom, that 50 cal is the best 50 cal I've ever had engineered, then I failed, right? We are going to be successful when this becomes just the part of the way we engineer.
Just the way we do it. That's a good way to summarize it. So we one last question, and I know we're running a tad long, but we're looking at each other's environment, which we don't record, but your personal work environment, how has the pandemic affected it? Are you working from home all the time? And how did digital engineering help?
So digital engineering actually hasn't gotten to help in the area in actually promoting digital engineering, interestingly enough.
Interesting point.
but I think only because, there's multiple layers to everything we do in the Pentagon. But I think digital engineering, even just the thought of being able to do things digital, that has been accelerated by the change in our work environments. Whether or not the subject happens to be doing this podcast, this wonderful podcast with Thom and Craig, or the subject has to be being able to share designs over a classified network on, the next ship. Right. The fact that we are all becoming more reliant and more, maybe less tolerant, but I'll say more tolerant of the digital world has increased people's confidence in actually doing this in the engineering space.
Well, that's a good way. Yeah, that's excellent. Well said. So,
Thank you.
Thom, back to you.
Hey, Phil Zimmerman, thank you so much for joining us here.
Awesome.
This was so much fun. So thank you so much for joining us here.
You're very welcome.
And thanks to everybody who tuned in and listened. We would like it if you would join us here every single week for more thoughts, ideas, and information in and around product lifecycle management. And make sure you tell all of your friends at work, your other colleagues, that you listen to this show, because people find the Digital Enterprise Society podcast most often through word of mouth. So go tell somebody. And remember, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out right now at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.